OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100 plus active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections, and recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Sean Wright here. He'll be speaking on open source software supply chains. Very excited to have Sean. He's coming to us across several time zones, so very much appreciate that too. It's later his time, I believe. But Sean is the Principal Application Security SME at Immersive Labs. Long history of contributing to the security space. Initially started as a software developer, has now moved over to kind of full-time security. And I believe you're also the product lead for Immersive, or security, product security lead for Immersive too. He's also the leader of the OWASP Scotland chapter. So pretty storied history as far as security goes. Awesome. Well, before I turn it over, Phil, to you, let me run through just a quick forward here as well. Let's see. Quick thanks to all of the current chapter board of directors who put these meetings together and kind of make this happen. If anyone has any good ideas for speakers or topics, please let us know, and we'll be happy to kind of try and create a meetup for that. And we recommend everyone go and check out our OWASP LA YouTube. We have a lot of recordings from previous speakers. This is all being recorded and will be uploaded there too. Lots of great content going back years and years and years. So recommend checking it out. Also, OWASP just had its 20th anniversary. So pretty incredible. There was lots of great topics, and all of it was also recorded. So if anyone wants to go back and check it out, you can go to their website at 20th anniversary OWASP.org and can go to their YouTube. If there's any sponsors who are interested in sponsoring these meetups, let us know as well. We're always interested in discussing. Next meetup, we're going to have David Henry, who's going to present on cloud security and IAM for developers and DevOps. So if anyone's interested there, please do attend. And then finally, without further ado, I will stop speaking and we'll hand it over to Sean. So big thanks again to Sean. I'll go ahead and stop sharing.
Yeah, so thank you for having me. It's a great pleasure and honor to be here. Pretty interesting to see how fellow chapter runs the meetings and that. So there's certainly some things I'll take away from the way you've done it. Some pretty cool
Usually
stuff.
smoother, I would say, but maybe not too many takeaways.
But and likewise, if anyone is interested at all for the Scotland chapter, speaking there, we always looking for speakers. So please feel free to shout out. And yeah, just some quick clarifications on co-leader. So I'm not the leader of Scotland chapter. I just want to make sure I give a shout out to Rob, who's also co-leader there. And yeah, so from Immersive Labs, I'm the product lead on our application security offering. We have numerous things, but that's not what I'm here. I'm not here to talk about Immersive Labs. I'm talk about supply chains. This is a topic that I'm quite passionate about. I kind of first started really getting involved with this and probably later half of 2018 into 2019. It kind of became something that I saw happening quite a bit when I was working my previous role, which was with the security company, and they did a lot of development in-house. And one of the things was software libraries, and that just being used, and the way they were being used wasn't really great. And to me, it started becoming more of a thing that I'm not saying I will ever do this, and I never ever will do this, but if I was an attacker, what better way of compromising an organization than going in via the supply chain? So hopefully this talk will help cover some of those areas, highlight some of the risks that organizations can face, and then we can go and see some like kind of live demos of some of the one type of attack, so a relatively new one, and then some of the tools, which are really awesome. One of them is an OWASP tool as well. So when starting off, I think much like I often do with application security when I give talks around application security, I think around supply chains, this is just as relevant as important. So if you're going to look at the way organizations used to develop applications, back in the day, certainly when I started, like almost 20 years ago, feeling really old now, companies built everything internally. You never had this notion of, oh, you just go off to the internet and you can just pull down all these sorts of libraries and frameworks and out there. There may have been libraries and that, but they're all developed kind of internally, in-house, and maintained. So from a security point of view, that's great. I mean, you have a lot more visibility, you have a lot more control, but from a business point of view, it doesn't make sense. Why are you going to go reinvent the wheel? And to some degree, some of the security may not even be that great. So if you're talking about things like cryptography, getting some developer to develop that who's not really a crypto expert, probably not the best from a security point of view. Rather get those who know what they're doing developing that functionality. But by and large, like because everything was developed internally, you probably had a lot more visibility and control around it. And similarly, the way that applications were then released or new features were released, we used to do these big monolithic releases. So you're talking about like a quarterly release or once every 6 months or something like that. And yes, there was a lot that went into that release, but it meant that you can really allocate time and resources and the whole works to try and review and test and make sure everything in that release is as secure as possible. You could dedicate a team, what, two weeks, maybe even longer, because you knew when it was coming. You knew that release was going to be this date and you could plan accordingly for it. And it wasn't very regular. It's not like on a monthly basis. But if you now have a look at the way we develop in software today, it's totally different. So one of the things I think of modern applications is it's no longer building things from the ground up. You kind of gluing all these different pieces together. That's the way I view modern applications. Think about it. You're taking a framework, you're taking all these libraries, and then you're piecing them together with some code to develop the functionality that you want. Now, this is fantastic from a business point of view, because now you can really move at the speed that the business needs to. And businesses are needing to move faster and faster. You also then have the benefit of not having to reinvent the wheel. If you find a library that does exactly what you need, why spend the time and effort to build that when you can just pull it down from the internet? And that's great. But there are risks associated with that. And we'll see in a bit. Then we also look at the way we releasing these applications. So gone are the days where you had these big monolithic releases, and now you've got things like CI/CD, where releases could happen on a weekly, daily, or even periodically every so few hours. So again, from a business point of view, this is fantastic. You're getting that functionality, you're getting that new feature set out to your customers a lot quicker. But from a security point of view, it can be an absolute nightmare. Gone are the days where you could just throw a team at this to go review every release. you can't have a security team doing an hourly job of trying to review these releases that are maybe going out every 4 hours or so. It's just not going to scale. So we have to change and adopt the way that we deal with these things. And in terms of libraries and libraries and frameworks that we use, this is going to be even more important because we need to make sure that what's ever been used in there is appropriately controlled in that. Back in the day, coming back to the back in the day and the future, the current actually, back in the day, you might have been asked like, well, why do you want to use this outside library? Well, now you'd probably be asked, why aren't you going to be using that outside library? And it has fantastic benefits, but it also carries risk. And it's something that I think is going to become more and more targeted by attackers.
Standing.
So one of the problems that I see is if you go look at just the sheer volume, and I'll come to some figures, there's just a massive wealth of software and code out there. It's just staggering the amount of lines of code. So one of the things I always chuckle at sometimes is, yeah, it's open source, you can go review it. Well, you're talking about not just thousands of lines of code, you're talking about probably millions of lines of code. And there's no way a human's going to be able to go and review every single line of code. So for attackers, this is going to be a brilliant dentist to hide themselves. So they could essentially, it's like trying to find a needle in a haystack. And then that's just maybe one library. Then you got a library that has transitive dependencies. So a library with its own dependencies, so those libraries and so on and so forth. So you can just suddenly see how this problem just scales and becomes a big thing. And that kind of feeds into these figures. So this is taken from the current report from Sonotap, the 2021 State of the Software Supply Chain. And those numbers there are actually kind of mind-boggling in a way. So the year-on-year growth for global supply of open source, just open source, so we're not even considering commercial services and libraries and that, is 20%. And you're talking about over
down the dead ones.
6 million, 6 million versions, and the number of new projects is also just massively growing. And then you also go look at the times that things are being downloaded is staggering. I mean, 2.2 trillion open source packages requested. And this is growing pretty significantly, a 73% increase. Probably a bit of worrying is the 29% popular packages that have at least one known vulnerability in them. And I think this is one of the bigger problems. So I've worked with development teams and that, and it's like libraries are really great, but teams generally don't do a good job of trying to ensure those libraries are up to date. So generally you find that those libraries were up to date or the latest version when that piece of functionality was developed. And as time goes on, it gets older and older and more vulnerable. Vulnerabilities find themselves within that library, and unfortunately they don't get patched often. So while that 29% is kind of the current, it's probably worse than that because people don't patch things as well as they should. This is kind of now pointing to where the reason why I say I think these things are going to become more and more targeted. So there's a 650% increase in software supply, the targeted attacks on software supply chains. And this represents a 230% increase over last year, where last year was reported as 430%. So you can see that attackers are starting to turn their attention to this. And think about it, it makes perfect sense, right? If you're going to go try to breach a company, you often got to try to find the way in, get to production server, find vulnerabilities in that. Well, what if you compromise a package or create some malicious package? You automatically probably going to have a high likelihood of being embedded in the production instance, because guess what? That's where the library runs. It runs with the software, right? And then from there, you probably have access to not just one organization, but multiple organizations. So in terms of attack and return investment, it's fantastic. And then you combine it with all these massive numbers, it's incredibly difficult to try to find these problems and then prevent them. So what are the types of attacks? Well, there's different ones. So dependency confusion is actually a pretty new one. I'll explain it a bit because I'm actually going to do a kind of live demo trying to illustrate that attack type. Typo squatting generally relies on not just missed punctuation, so maybe typing or leaving out an O in a package name with the O in it, maybe putting a 0 instead, but also just playing on the name. So there's a real world example, which we'll cover later, that was a typo squatting that used this. Malicious source code injection and malicious package. So I kind of view these two differently. So malicious source code injection is probably where they've compromised the account of the author of the package or library, and then they've actually embedded their malicious source code into that package. A malicious package would be typically something that a attacker fully owns and controls, that it's their package, but they're probably set out with a legitimate usage in the first place, so they could get people to download it and then inject the source code in there. Or maybe just start it off straight away with the malicious source code in there. But the difference between the two is the malicious source code injection is where the attackers compromised a legitimate author's account, and the malicious package is something the attacker purposely created that package for. Build infrastructure and build system compromise. So we saw this with SolarWinds. For those who aren't familiar, SolarWinds towards the end of last year, their build system got compromised. And the reason why it's a really juicy target is because of things like signing keys and that. Generally, if you compromise the package, you have to then somehow re-sign it and all of that. But if you compromise the build server, because part of that build process would be to sign the package, well, guess what? You can inject the malicious code neatly inside the build, and then it will be all signed, and everything will look fine. And that's what happened with SolarWinds. There was a malicious DLL injected into the build, and packaged and archived in an update that went out to customers and caused a lot of problems. So yeah. And then lastly is kind of attack. It's where there's a vulnerability in the library. Attackers would just target that vulnerability and exploit that vulnerability. And there's perhaps the best example of that is Equifax. So some real world examples. So earlier this year in April, CodeCov, which is a code coverage tool, they were compromised. Now they use a bash script, a bash uploader script, and the attackers were able to modify this. And then this allowed the attackers to inject their malicious code in, and the end result was there was a potential of customers losing sensitive information. So this could have been things like tokens or credentials or API keys, that kind of thing. Because it's code coverage, kind of more testing, so maybe a bit limited. Hopefully, keep the testing sort of credentials and sensitive information separate from the production one, but that's not always the case. URAparser.js. So this is an NPM package. October this year, the attackers compromised the author's account, and they then injected a crypto miner and a password stealing Trojan. So obviously the intent was to mine crypto and then steal sensitive information. And interestingly, thankfully, the specific version, there was only one version compromised, and NPM was pretty quick in taking it down. But UA parsers even used by tools like CyberChef, which is used quite extensively in this security community. That version used by CyberChef wasn't affected, but you could see it quite easily could be. So yeah. NoBlocks.js. So this is an example of a typo spotting. So again, October this year, another NPM archive. And these ones are probably harder to prevent because of the open nature of open source, and one can go off and kind of create these packages. And the typo spotting wasn't playing on like MB blocks or N blocks or whatever. It was like no blocks dash proxy or something like that, or no blocks that release, or just adding snippets on the word. So attackers were trying to get people to use those instead of the official package. And that contained MBR lockware ransomware. So I'm not too clued up on all the ransomware flavors, but it's assuming that NoBlocks is part of the Roblox game. They're probably trying to ransomware the victims part of the game to get them to fork over money to unlock their game or whatever it was. So yeah. Now this this package, yeah, just really got me scratching my head. So I first came across this package from a Bleeping Computer article. The package name is literally dash, just dash. The package does absolutely nothing. There's no value at all in using this package. If you go look at the source code, you can use npm install dash, or pull the package down. You can view the contents of the package. You can see it does absolutely nothing. The worrying thing with this is if you go look, over 21,000 weekly downloads and 77 dependent packages. So 77 other packages, you have this package as a dependency. And this package has no value, absolutely nothing. So this points to that problem where people are just assuming, okay, it's on the internet, it's an official repo, so therefore we can trust it. So I wrote a blog post on this if you're interested, seeing all the details. That number there is actually higher than when I actually wrote the blog post last week, which is kind of scary. And yeah, it just shows you the extent of the problem. So how we solve this, I don't know, but there are some tools that we can use to hopefully help limit this problem. All right, so what I'm going to do is I'm now going to try share my browser. Just going to make sure I get the right tab. Sorry, I just do find tabs. All right, so those. All right, so this is going to be a demo of the dependency confusion vulnerability. The point of dependency confusion is that it relies on the fact that package managers download firstly from the public repository before they'll download from any private repository. And the way this attack works is the attacker needs to know the package name that they want to target, and then the current version. So package X on version 1.1. The attacker would then create package X 1.2 on a public repository. And then that way the package manager would then try to pull 1.2 from the public repository first before it tries the private repo. And that way they can compromise that package. So in this case, what we have is make-believe PyPy, because I obviously don't want to compromise the legitimate PyPy repository. So this is the official PyPy repository, which it's not, it's just local to this instance. And there's all the packages there. We also have this site called humble.py. So this is kind of like some websites, Flask-based websites, and unfortunately, the developers left the build log lying around. Let me just double check what the build log URL is. Okay, so I don't know why the build log's not there. There we go. Maybe it just took some time. So accidentally they left the build log lying around, and one of the things to note is there's this package called Flask or Humble Pie, and you can actually see the version. Now, what an attacker would do is go along and start kind of creating a payload for themselves. So first, I'm just going to create like a kind of beacon, so the payload actually knows when it's connected. And Flask. Would help with a type problem. Flask auth. It's there. So I'm just going to copy my IP address, my targeted victim, which just will be this box that I'm currently running on, just for demo purposes. And I'm going to create the package setup. Spell correctly. There we go. And I'm just going to copy this payload. Now, what this payload is going to do is just going to connect to a local shell, and then it will, do its thing. So assuming that like this is the attacker, sorry, go the wrong way around. So this is coming from the attacker going to the server. So I'm just going to create a shell. And the next thing I need to do is create listening. I'm going to create port, and then lastly, I need to just make sure I compile the package. So we're going to build the package. And then upload it to the official repository. So there we go. So if I now come back to the repository, we can now see Flask or Humble Pie 4.23.1 is now available, and the app is using older version. So, and you can see now I've connected. So reverse shell's there. I'm on the server. Now I have access to the server. Obviously, root's not a great thing to be running as, but yeah. And then the last thing I can do is just to show that I've actually got access to that server. I am going to just do a really simple, mundane, silly, what do you call it? Defacement attack. So I'm just going to modify the index.html. So basically the landing page for this site. So if I refresh this, it should unfortunately not work for me. Sometimes it just takes a bit to rebuild. And there we go. Yeah, so deface the site. And that's the dependency confusion. So it worked by uploading to the malicious artifact or library to the official repository, because dependency managers pulled by default from the official repository of public repos first before any private ones. That will then compromise that. Another important thing to note, I've seen this happen quite often in terms of malicious packages and that. The vendors are pretty good often. So you're talking about folk like NPM, they're pretty good at removing them. One thing you have to remember though is with private repos or even build servers, all that is cached locally. So with private repos, you probably have a proxy. So even though it's removed from the official public repository, it's not necessarily going to be removed from your private repos or any build server with its local cache. So one step is when you see these malicious repositories, you need to make sure that you go off and identify anywhere in your entire organization where those could be used and if they're still around, and then obviously delete them if they're still there. Cool. So that's a demonstration of dependency confusion. The next thing I'm going to go on is kind of now going on to, well, this is all great. This is alarming and all of this stuff, but how do you actually deal with this stuff? What are the things that you could do to help prevent these types of things, or at least limit it or get better visibility of these things? And one of them is, as I said, I'm going to show you OWASP tool is Dependency Track. Now, no secret, I'm a huge fan of this tool. I think it's an amazing tool. Done an absolutely fantastic job on this, and it's something that I'm publicly vouch for, and I think it's really useful and well thought out, and any organization should be using this because it's worth its weight in gold. Just quickly going through it, you've got all these lovely graphs and that showing you all the different kind of scores and vulnerable libraries and that, and you can go off and go create your own projects. So in this case, I've created some different projects here. You can then see which of these projects have different vulnerabilities. I'll come back to that. You can also see the components in terms of the different projects. Actually, don't know why any aren't showing up here. It's probably because I haven't searched for them. And then the vulnerabilities. So this is coming from MVD and NPM, so kind of public vulnerability databases. So you can see there's MVD and then NPM as well. It's also got licenses. So if you worry about things like FOSS, you can do quite a bit of FOSS as well with this tool, which is awesome. And then policy management. I haven't played too much with that. And then lastly, you can create things like teams and have integrations. So you can have things to fortify that. And I think there's even things you can connect it to the like of Slack and Teams and that kind of stuff. And there's the kind of some paid for analyzers. So VulnDBs is an example. Some of them are free, like Sonatype OSS Index, which is pretty good as well. So coming into this, what you would do is you have your project, and then you'd have to scan your project. Typically, the way it works is you scan the project, you generate what's known as a bill of materials, which is basically all the dependencies. That includes direct dependencies as well as any transitive dependencies. So dependencies of dependencies. That all then gets imported into this tool, and it'll scan those and then compare them to the vulnerability databases. So by default, NPM and NVD. And then it provides you with these nice kind of visual aids on the landing bits. But obviously the important bit is actually seeing what the vulnerabilities are. So in this case, we can go see, okay, well, Commons collection has one high and one medium vulnerability. And you can drill into that and actually see the vulnerabilities itself. So in this case, critical and high vulnerability. And then you can actually go get further information from itself, from it. So you can get things like the CVSS score, the CWE, and then additional links to it. This here is actually also worth its weight in gold. I can't stress how important it is to understand a CVE or a package, effective package, where that's used in the organization. when Apache struts came around, we were running around headless chickens going, oh my gosh, where are we using struts? What versions are we using? Which projects? With a tool like this, you can just simply go into your components. So I don't know, in this case, what was this? Commons collections, and you can go to components and you can, I've not used this that much, so there we go. So you can go into there and then you can start seeing where you've actually used it. So which projects are actually using this, and it's worth its weight in gold. So you can immediately see where you have to go and update this library, and what sort of risk that library then presents. So you can get all that information straight up front, and that is just so powerful. As I say, like sometimes these things are really difficult to prevent, but at least having a notion of a knowledge of where these things are, you can put additional controls around them. So even if that library isn't fixed or there's no known fix, you can go, okay, well, these applications need additional monitoring, or we need to suddenly put them on firewall. If they're internal use, you may want to just remove any internet access to them. That kind of stuff. You can then act and try to reduce the risk. The other cool thing that you probably saw, it also tells you when libraries are out of date. So you can see from here, it knows when these different libraries are kind of stale. So it doesn't necessarily mean it's a bad thing, but it may be something that you want to go look at. And this is also pretty cool, this dependency graph. So you can see where the affected libraries are, and it just makes it easier to see, like, okay, well, this is the impact that it may have. Like it might have more significant impact, because sometimes updating a library is not just as simple as changing the version number. It could have an impact on another library if it's a dependency on that. So this is pretty useful. And then you can also audit these vulnerabilities. So you can create comments and analysis, and you can suppress them. So you know what? Yes, this vulnerability is in this library that we use, but we actually not using that feature. So therefore, we will say, okay, well, not affected. And then you can put in the comments. And it's all tracked and it's all great. And then you have integration, I'm pretty sure, with the likes of Jira and that. So that's this tool. Now, this is all great, but you need to have this as an ongoing process. So any new libraries you need to detect. And even better is, can you even prevent builds if it reaches a certain threshold? And that's where something like the Dependency Track Jenkins integration works really well. So as you can see, I've created the projects here, and it works really well. It's a plugin, Jenkins plugin. And if you go to configuration is really simple. In the global configuration, you just basically throw the URL of your dependency track, as well as a key, an API key, so it can authenticate. And then per project, you just configure where the BOM is, so the bill of materials. And then I'll come to these other two things in a bit. And then when you run the build, you have to get the build to generate a BOM. So in this case, I'm using Maven, and there's a Maven Cyclone DX plugin that will help generate that bill of materials from the build. It's a Maven plugin. So if I run this, as you can see here, I'm not going to run it just to save some time. You can see it's generated this bill of material here. Yeah, take my word for it. I can't remember where it does it, but it generates this bill of materials, which is over in Target by default, and then BOM generates both the JSON and the XML. And then that gets uploaded to Dependency Track. You can put it manually, but it gets uploaded and does its magic. Now, where the really powerful thing is if you come to the configure, you can actually warn and create different these thresholds. So in this case, what I'm going to do is create the build to become unstable if there's any critical vulnerabilities found. And I'm going to kick this build off and off the run. It's doing its thing. Of course, it has to download everything again. Hopefully it won't take too long. If not, I've done another build with that. Oh, it's going to take a bit. I'll just come to this one. You have to take my word for it. But as you can see here, it's created a warning one or more dependencies were identified with the known vulnerabilities. So you can start setting these, okay, well, we need to alert now. We won't block the release or we won't block the build, but we need to pay closer attention to it. And then because that's taking a bit, I'm not going to do the other one, but you can actually then also come into the configure and actually block a build. So create the build to fail if you have these critical whatever metrics here. So these are total, so any overall or any new ones, you can even go down to that sort of level of granularity. And in this case, this build here, okay, so there we go, you can see it failed. Showed you, there we go. It didn't fail, it just had a warning. So if we now come back here and modify this, so remove that, actually, you know what, we're going to fail on any critical findings. And the build should now break. So what it's done there is uploaded the bill of materials, and now it's waiting for the result back from dependency track, and then you can see that it failed because it exceeded the thresholds. So that's a really good way of controlling vulnerabilities. So you can start setting thresholds that you consider and deem not acceptable from a business risk perspective. Yeah, there are other tools out there. So there's OWASP Dependency Track, which again you can run with the Maven plugin. That's great for kind of ad hoc things, but one of the limitations is it just produces a HTML file, which is great if you just want to check something off ad hoc. But if you're trying to manage your own internal kind of dependencies in that, it's not going to really work too well. You want something like Dependency Track. There's also, if you use GitHub, there's Dependabot, but again, that's only really per project. So it can do automatic alerts, and it's pretty cool how it can also try to do an automatic update. So it will do an automatic PR to update to the latest version in some cases. And that's great, but again, you don't have that central correlation of all the libraries and dependencies that you're using. It's still very much per project. One other thing I want to show you is Snyk have a pretty cool they have a pretty good vulnerability database. So SnykDB, it's vulnerability database. So in this case, if we wanted to come here and see this, so commons collection. So you can see all these things here. So if we're looking for actual specific CVE, which is this one here, we can actually also search on the CVE, which might be easier. Oh, okay, maybe they don't have that one. Maybe not a good example, but again, I'm actually pretty surprised on that, but CV are generally pretty good. But again, this is probably pointing to one of the reasons why you probably don't want to just use one kind of source of truth for your vulnerabilities. The more kind of input you get, the better coverage you're going to get. So yeah, in this case, you can see in our score. One of the problems with the scores is the score on its own is often not very useful if you're trying to triage a vulnerability. You need to know things like, is it network exploitable? How complicated it is to exploit? Is user interaction required? Like all of that kind of stuff helps a organization assess that vulnerability for themselves and determine what sort of risk it presents to them. If it's not a network accessible and it's a server stuck in a data center somewhere, then organizations are probably going to deem that pretty low versus something that's maybe sitting on the internet. So that kind of stuff is why that information is really relevant. I know this used to have it, but I think this was taken away. It used to have the actual vector, which had all the information, but unfortunately it looks like it's gone, which is a bit unfortunate, but you can always just try to go look up the CV itself and get that information. But yeah, I think Sneak may also do additional research on these vulnerabilities. I know organizations such as Sonatype, that's where they add their value. So they have their own commercial products and they do their own further investigation on any sort of vulnerabilities and libraries. And that's why you pay extra for those products as well. And they have a whole wealth of other things like Sonatype Firewall. So you can set all sorts of policies on even preventing dependencies being pulled into an organization in the first place. Pretty good stuff, but it comes at a price, unfortunately. Yeah, so that's pretty much all that I had. Yeah, any questions? The demo gods were kind to me today.
If anyone has questions, feel free to unmute or even put in the chat.
I have a question. It's I guess about the larger ecosystem. I've been looking at tools that might hook into Dependency Track, and we have been approaching it from the standpoint of generating bombs at build time, and I like that approach, but I'm afraid there's going to end up a lot of stuff in Dependency Track. I see it has integrations with ThreadFix and Defect Dojo as maybe a couple open source projects. Can you comment on what of those you like and whether you do like them and if you have any experience with them?
See if we can get the integration. So I've had a look at Defect Dojo. I like that. I think it's a really good tool. I've not used it too much in the commercial environment, unfortunately. When I started looking at it, I left that role. So I haven't played too much in the commercial environment, but I think it has a lot of potential. Things like Kenna or, ThreadFix, again, it's that central view. I think that's one of the problems that organizations battle with is they at times may look at all these vulnerabilities in isolation, and it's difficult to assess the risks or organization because often it's not just one vulnerability, it's a chain of vulnerabilities that leads to a compromise. So you need to take all the vulnerabilities in context with one another. And if you got something in even OWASP Dependency Track and then, I don't know, NetSparker and then Fortify, they're all disconnected, so you can't have that central view. So I think correlating the results is definitely the way to go. Hope that answered your question.
Yeah, I mean, I think we'll learn going into it and figuring out solutions to deal with the volume. And we haven't got to the point as an organization where we've broke anyone's builds, and it will be educational to see when we get to that point what the reaction is. So even with fair warning to developers. So
yeah, and I mean, I think most people, well, I think a common mistake is going in guns blazing, break builds. One other approach I would go is go more cautious. Yes, you'll have a lot of false positives, and you're not going to prevent anything, but knowing something is far more valuable than knowing nothing, right? So even if you don't do anything about it, but you know about it, that's far more valuable than your previous position, which is
Right.
having no idea.
I think that's going to be our approach, is just hook everything in and just measure for a while and see where we're at and try to assess what matters, right?
Yeah, and then from there you can go like on education and awareness and that, and start showing these different things to your development teams and that, showing the impact and making them realize like this is why you need to update these libraries, and then you get buy-in from them and you can work with them to bring that number down in a way that fits them and yourselves as well.
Cool.
Collaboration is key.
Yeah, it's easy to want to fall back into, I think, into old habits and want to be the department of no and with the bad hammer, right?
But us security people, never.
Never, right. Cool. Thank you.
Kind of have a follow-up question on that point. I think with I'm curious how you see the balance when managing some of these AppSec vulnerabilities. Like, what does that balance kind of look like between security and developers? Because I think you can go to the extreme where you are just pushing it all to the developer, but then you mentioned that, you know, it's not easy to use any of these CVE databases, and some of these vulnerabilities matter more than others. You know, I guess you could just kind of take the CVSS score and say, oh, it's a critical, patch it, or you could start digging in and really, you know, figure out how much of an impact it's really going to have. But yeah, I'm curious how you see balancing, like how much triaging kind of security should do versus like just telling the developers, hey, just keep these things updated, you know. Any thoughts there?
You have to include your developers in that triage process. They know the tools, they know the system, they know the deep level stuff. I had one incident where our vulnerability team was telling the development team, you have to patch this, you have to patch this. Why? Because there's a CVE and there's a rating, but we're not even using that functionality, so why? So that's why you have to work with the development teams. Be pragmatic about it. Don't just patch it because, you know, it's a CVSS 9 point whatever, and that's what it says. Find out if you're affected, which is not always easy as well. So if in those cases, you probably need to work with the development team and say, like, look, the amount of effort trying to work out if we're vulnerable to this is just that much more than just patching it. Great. But if you know for a fact that you're not affected, don't force it on them. Just try to get them to update as part of a cycle or whatever. Be pragmatic, work with the development teams. The other important thing is we as security professionals generally do a poor job of this, is explaining the why. Why should they patch it? Why should they care about it? I mean, even if go look at the way we do with things like cross-site scripting, it's an alert box. Well, developers are not going to care about alert box. Why should they worry about that? So if you can show you some of these vulnerabilities, like the patchy struts one would have been a great example. You can sit down and go, well, this is what happened, or this is what could happen. Then they might buy in a bit more because they understand it's not just someone saying it for the sake of saying it. And also give them a voice. I think that's an important thing as well. Is all too often they feel that they just ignored and told what to do. If you give them a voice, and they'll feel empowered, and then they may feel that they'd be able to contribute something.
I have another question. How do you like to handle the exception process using Dependency Track? And do you make that self-service to developers?
Depends the exceptions. That's a tricky one. The reason why I say is exceptions are going to be very, very careful, because I've seen it before where someone just doesn't agree with it. Oh, we'll just raise an exception. And the exceptions no longer are exceptions. They just become like a pass it off type thing. So you've got to be careful. It's that fine line between allowing them a way out if and when they need it, but not to the extreme where they can just feel they can use it as a means of just effectively bypassing controls and SLAs and that. So as long as it's enforced and there's a legitimate reasoning behind those exceptions, I think they should be empowered, but they need to know that those should be rare occasions, not the norm.
I think that answers a bit of the cultural aspect of it, which is key here. But from a technical aspect, how would you go about doing that with Dependency Track?
I've not looked. Oh, sorry.
I was going to say, where would you actually put the exceptions and build that in? I thought, and where I'm thinking on this, and I haven't built this yet, but I'm proving this out, is I was thinking about using Open Policy Agent and taking the output of Dependency Track with details on vulnerability, running that through OPA to put the business policy decision in that. But I'm not sure if I want to put those exceptions in the OPA policy. And I don't know if Dependency Track has a native way to do that. And it kind of ties back into the self-service aspect, like do I let, which again ties back into the cultural aspect you mentioned, do I let developers self-service on this, right? For that stuff, they say, well, this doesn't matter because we don't use this code path, right?
Yeah. So to be honest, I don't know what sort of exception process there is other than going in and going into the actual vulnerabilities themselves. So in this case,
So just going through that review process with them.
Yeah. So going into and then actually marking them off. So there are
maybe the question is, do you think all developers should have access inside Dependency Track?
They should definitely have access to Dependency Track. There are team roles in that, so you can make sure that you only give certain projects to the appropriate teams. Now, whether they should be allowed to mark things as false positives or not, I think that's going to largely depend on the organization. It is audited, so maybe there could be a process around, well, if you're going to mark it, you have to put a reason why, and if it's found out that it's not legitimate, then you can reopen a top thing or something like that.
Yeah, cool.
I have another follow-up there. I'm curious if you found, instead of approaching it from more of the criticality severity standpoint, have you found some success approaching it from more of like a, asking like what dependencies are most important first, and kind of keeping track of those, like, struts and Jetty are probably pretty high on the list and compared to maybe Lodash or something else. Is that maybe a sort of a fallacy or a trap, if you start heading down those lines, or have you found that to be kind of effective?
Actually, to be honest, I've never thought of it that way before. So one of the things is interesting you mentioned Jetty is, and this is the problem with the libraries, is some libraries are really bad at backwards compatibility, Jetty being one of them. I thought, I'll just update it, it'll take me easy. It took me like 2 weeks to fix it because there was that much work involved. So I think trying to approach it from different specific libraries, I don't know, because at the end of the day, what is security? It's trying to reduce the risk. And the risk is, regardless of what library you're using, it's all about the vulnerability and how it impacts that specific application that's being used. Now, interestingly, you mentioned that risk and libraries and that. There is a project called Google Salsa. I'm vaguely familiar with the concepts around it. Don't quote me, I'm no expert, but I think the attempt of that is to try to get some scoring metrics to the different libraries. So how often do they patch things? How often do they update? How responsive are they? So maybe that's an approach. Like you start looking at these different scorings from Google Salsa, and then you can start working your way down from there. And that kind of, I think, lends itself well to what you're suggesting.
Yeah, that's awesome. I'll have to check that out. I haven't heard of it.
SLSA, Google Salsa.
SLSA, gotcha.
Yeah, it's part of the, I think it's OpenSSF, that whole project they're doing to try to tackle some of these the issue around open source software libraries and that, because it's it's a minefield.
That code path point is, I think, pretty interesting because, like the more those libraries are in the code path, like it's almost like code path times severity. That gives you like your final ranking or something like that. But I've never found a really great way to evaluate, or go any deeper than kind of the CVSS score, which is tough. So
this is where I like also say that you got that trade-off of how much effort you can actually put in evaluating it versus updating. Most of the libraries, it's just updating a minor version, and it's literally just going in and updating a 1 to a 2 in the library, but not always. Like as I mentioned, Jetty is a good example where it's not quite as simple, but thankfully most libraries are like that. So I think one area that helps a lot for this is automated testing, which companies should have, especially on CI/CD. So having that good hygiene around other things can certainly help. Not going to say it's completely eliminate the risk, but it should help with those types of things. If you go look at Equifax, and this is the thing I keep on coming down to, and it just boggles my mind. So if Equifax was doing things correctly, that should have been a one-line change in their build version somewhere. We're using version X of struts. Should have. Probably not, probably a lot more complicated than that. But potentially that one line cost the company over $1 billion. So yeah, and as I said, it's a difficult problem to solve. I know developers generally just use the library at the stage that they initially import the library and don't look at it again. So at least maybe putting some of these metrics in front of the developers might wake them up a bit and make them realize like, hey, sometimes these things do get out of date and have vulnerabilities in them. Any other questions, or anyone want to see anything else at all?
Sweet.
Thank you again. Thanks for having me. It was great. Be part of it.
Yeah, thanks for taking us through that. It's great discussion too. So appreciate you joining us late again, Sean. So sounds good. And thanks everyone else for attending. Appreciate it.
Thank you, everyone. Thank you, Sean.
Yeah, thank you.